Hello, welcome to part 2 of the programming with Python. You can revise part 1 and catch up if required by following the link. In part 1, we learned about variables whereby we assign a particular value to a variable. Say x is equal to 4, for example. X is the variable and then 4 is the value we assign to it. We also learned other things like that the program always executes line by line. But in this part 2, we'll see that there's a way we can make it different. We can assign more than one value to a particular variable. And there's a way to have more than one value, a different way of running the program, maybe. But we'll see that later in this part. So in Python 3, we have this concept called collections. So there are different types of collections we have. What we're going to look at in today's video is what is known as lists, tuples, sets, and dictionaries. So these are some of the common ways assigning maybe more than one value to a particular variable. And then from there on, you can manipulate them. So today we are going to be using Pycharm Ide. This is what the interface looks like. It's more interactive. It's a bit easier to use than the Wing 101 we've been using. You could also use Wing 101, but today we'll just use Pycharm. You could also use the website Republic as well. So let's look at lists. So as we mentioned initially, when we have variables, so you could say x is equal to 4. For example, you just assign x to 4, and if you print, so one of the advantages of having Pycharm is autocomplete some things for you. So you can use either this, so it's even giving us some suggestions. So you could use this run button here, or run from up here, or maybe run from the one here. But I'll maybe use this one more often. So you click run, you see the output here. So 4 has been printed because we assigned the value 4 to x. But what if we wanted to assign more than one value to this x, this variable? So you could have a list. So you say x equal, then using a square bracket, say, let's say 1, 2, 3, 4, for example. So we've assigned 4 values to x using a list. So if you say print x now, let's see what we get. So if we print x, you see here we have 1, 2, 3, 4 at the output. So that is basically how lists operate. The good thing about lists is that you can assign more than, not just numbers, you can have other values, integers as well. So let's look at what happens. Sometimes we might want to create an empty list. So you could do that by saying x equal and just put the square bracket like that, empty square bracket. Or there's a function actually called lists. So you could just say x equal list. And then don't forget the bracket because it's a function. So if you print each of these, it should give you the same. So print x, and let's have print x here as well. So when we run these 2 lines, so you see you have these 2 brackets here. It's 2 empty lists. So sometimes this is important. You can use this maybe later when we look at flow control. You can create this empty list. Then later, as you run your program, you can ask Python to store the results inside the list. Just be adding it to the list like that. So we'll see how that can be done manually. So as I mentioned also, we can have more than one type of data or value. We can have strings as well. So let's say, okay, let's comment this out for now. Control backslash to comment out those lines. So we could say x equal 1, 2, maybe have a string J, we put the float, for example, 0.4. Okay, let's have this. So if we print this, print X. So if we run this now, so you see we have exactly what we entered into the list. So lists are very important. You can have more than one value. You can have maybe, like, let's say, storing usernames that you use later on. So you could have something like usernames, then maybe your square bracket. So let's say we have J, you have Ali, have Mike, for example. So these are usernames. So if we print usernames, print username. The good thing with Pycharm is that it actually gives you suggestions. So it anticipated I wanted to print usernames here. So it already gave me the suggestion. So I just press tab and it will complete it for me. One of the advantages of using Pycharm. But sometimes maybe you shouldn't start using it immediately because you might not. So that at least you learn how to type some of these commands. Then when you now switch to Pycharm, it's much easier. So you can see you have the usernames that we just entered here appearing. So other things you could do with lists is you could find the length of the list. So run it now. So you see it's telling us that in X we have 4 items, whereas in usernames we have 4 usernames stored over there. So this is one way of looking at that. Another thing you could do is finding the index of a particular item in the list. So the index, it starts counting from 0. I think we saw a bit of that in the, if let me just comment. Okay, maybe we don't need to comment with the with strings. So if you say print, let's say X at index 0, for example. So it starts counting from 0. And then if you run this, you'll see at 0 we have the number 1. Let me just comment this. Let me comment this out, for example. Control. So let's run it again. So at 0, we have number 1 here for X. If we change this to at index, let's say 2, and run it again. So at 2, we have J, because it starts from 0, 1, 2. So at 2, the index there is J. So the same thing if you use for the username. Usernames at index 2, what do we have? 1, 2. We have Mike at index 2. So you see it has printed it out. Here's the output. So that's one of the things you can do with lists. Another very important feature also is if it using negative. So if you do -1, index at -1, it will give you the last item. So it starts counting from the back, which is Mike as well. So if you now say print X -1 at X, it should give you 0.4. You can see here, 0.4. So it starts counting from the back. If you use -2, for example, it should give you J now for the X. So it's counted from the back as well. So this is one of the advantages of using lists in Python. So other options you have is that you can maybe get a slice, as they call it. You want to know maybe index, let's say from 0 to the colon 0 to 2, for example. You want to print the values in those index. So it gives you 1 and 2. So you see 1 and 2 here. If you don't indicate the first item, just put it like that, just colon and 2. It will assume you should start from the beginning. So it's counted from 0, 1, 2. But not including 2 itself. You don't include the number you put. So if you want to have 3, then up to index 2, then you actually put 3 here. So that's how it counts it. Then if you just, let's say you put index 1 and you don't put the last index, it assumes you want it to count from index 1 to the end. So it starts counting from 2j 0.4. Another way is if you don't put anything, you just put it like that and you just run it, it gives you the entire list. That's just the semicolon without the indicating any of the indices. Yeah. So there are some other methods you can use, like how you append a value, how you insert values, and the rest. So to do that, we can just say for x, we want to append another value to it. So we'll just go ahead and say maybe we have 1, 2, 3, 4. X 1 to j 0.4. So we want to append. Just erase this. So we just say x dot append. So he's already given us option. So we want to append the number 5 to x. What it does, it goes to the end and adds that. That's what append means. So if you now print x, what do we see? You'll see that the list has an x, a 5 in it. So the original x here is 1 to j 0.4, but we appended 5 to it. So we have 1 to j 0.4 and 5. Another, you could also decide to insert. So let me just erase this append and just put insert. But with insert, you choose the particular index where you want it. So it has already given you the hint here. Index where you want to insert. So let's say I want to insert the number 6 between value 1 and 2. So the index is at index 0, 1. So at index 1, I want to insert number 6. So you do that and just put 6. So insert actually. So when you run that, so you see you have 1, 6, 2, j 0.4. So the 6 was inserted at that particular index. Another thing is you want to remove a particular value from the list. So you could just use the remove method. Remove, and then the value we want to remove. So let's say we want to remove that 0.4. So remove 0.4. If you run this, so 0.4 is missing from this list here. So we have 1, 2, j, but no 0.4. Then lastly, another one of the methods we want to show is called pop. So pop, you could put the index where you want to pop from, or just leave it like that and just run. So what it does is that it goes and removes the last item on the list if you don't apply any, if you don't specify the index. So there are other methods you can use the list. So once you just type the list and you put the dot, you see so many options here. You could copy, pop, clear, count, extend, index, insert, remove, reverse, sort. You can sort the list from lowest to highest, or you can reverse the list particularly. And there's some other class items here if you look at feature class. So that is all about lists. They're the most common ones among the collections in Python. Next, we look at tuples and sets and dictionaries. We will now look at tuples. Tuples are like lists, but the difference is they are not, you cannot change them, unlike lists. In a list, you can change the list, you can add, you can remove items. That makes them mutable, but tuples are not mutable. That means once you create them, they remain where they are. So let's look at an example. Let's try and make a tuple here. So we say, let's say y equals, so use the double bracket, the rounded brackets, 1, 2, 3, 4. For example, this is 4. So this is our tuple. The difference between the tuple and a list is the type of bracket you use. That's how you, so you can see here is our list X, by the square bracket. Here you have the rounded bracket. We just comment out these lines so you don't. All right. So if we now look at it, you try the Y, so try to look at the methods and the tuple, and you put a dot. You'll see that the methods are not as many as when we had a list. So you see, we only have count, index, and then some other methods that we use with classes later. So you cannot add, you cannot append, and things like that. If we uncomment our list and we try the same to look in the methods in our list X dot. So you can see you have other methods. You have append, you have copy, pop, clear, count, extend, index, insert. So many things you could do to a list, but the tuple is very limited. So this is when you want to have a situation where you want to have a kind of collection that should not be changed after it has been created. So maybe say passwords 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, for example. So this is now a tuple. It looks like a list, but it's not a list. So if we, so this password is methods, so many. So you can only count, index, and stuff. If you had made this a list, for example, by changing the brackets around it, come here to check the methods. So now we can, because it's now a list, you can actually copy, pop, clear, count, extend, index, insert, and all the other items we have. So basically, these are what tuples are. Next, we look at sets. Sets are also a form of collection as well, but they are an ordered collection, and there are no duplicates in a set. So that's the main difference between them. They are unordered and there are no duplicates. So if you want to create an empty set, you see Isa gave us an empty set, which we can populate later. So with the set is it doesn't have duplicates. So whatever you put in the sets remain the same. So but you can look at the methods associated with them. With the sets, you can update the set. That's how you add values to it. The methods you could have discard, update, and some other. You can add, you can clear, copy. But then one of the main differences is you can find difference. You can find the intersection, just like we have subset and there is union in the set. So it doesn't have duplicates. So if you enter more than one value, it does not accept it. So next we look at dictionaries. So dictionaries are a collection that has a set, a key and a value. You have keys and values. So example, you can make an empty dictionary by just using, let's say D, using this curly brackets, for example. So if you print that, it gives you your empty dictionary. And another method is using the function. So you have, let's say, Z equals, this gives you an empty dictionary as well. So this also gives gives you an indentation. So it does the same thing, gives you an indentation. So that's the difference between set and a dictionary. So the way you create, you have values and keys, as I said. So you have, let's have a student, for example. We have a student. So what are the values? So you'll say, so you have a name, for example. Then maybe an age. So let's have a student, and let's start. So have a student. So for a dictionary, let's have a student. So this is the name, is the key, and then the value assigned to that name. Let's say Ali. And then we'll say you have an age, and the value assigned to that age, let's say 20. And then maybe we'll have a subject, for example, or subjects, let's say subject. Subjects, and then we'll say we'll have a list for that, or a tuple. But let's have a list. Let's say English, maths. All right. So I've created our student in the dictionary now. If you run this, okay, it runs, no problem. So now if you want to access any of these key value, we could just say print student name. So name, for example. Print this. It will now give us what the name is. The name is Ali that we have stored under the student. So we can do this for any of the values there, because we are looking at any value we check to show us that. If you also try maybe finding the subjects, you will say print student subjects. So if you print that, it should give us. So it gave us what these subjects are: English and maths. So another thing we can do as well, you could update this. Maybe you want to add more values, so or change some other thing. Let's want to change the name of the student. The student is no more called Ali, for example. If you now come here, you can just say student. How to change the student name? Student name. Student name. So maybe it's no more Ali. We want to call this student J, for example. Now, if we now print our student, we print that now. This is the wrong bracket. You'll see that the name has changed to J. And if you just print just the student without the particular key, you see that all the values have changed. So the name now is JH20 subject English. And so that's how we update you can update the any of the records in the dictionary this way. We could also add a new value or any update that we did not have before. Assuming, let's say the phone number, for example. So we didn't have a phone number, so we could say student and phone, because we did not include the phone number. So let's say is the phone number. So if we run this, it updates the list. So if we now print our student, you'll see that we have an addition, which is the phone number. So we have the name, it's now J, the age is 20, subject, English maths, and then phone, 32. So that's how the dictionary operates as well. It has a key and a value. And then you can update it almost the same way, a similar way of updating the other collections. So in this lesson, we saw collections. We looked at this, which is maybe probably the most common one. So assign a variable, instead of assigning one item or one value to a variable, you can assign multiple items. And the difference between the lists and the way the list is, you have a square bracket. You have other methods with it. You can add, you can remove, update the list. Then we have tuples. Tuples are like lists, but you have the round bracket around them, but they are not mutable. You cannot change them. Once you create a tuple, it doesn't change. Then you have the sets. Sets are like lists as well, but sets they are unordered and they don't have duplicates between them. So if you can have you can have multiple sets and you can find with the intersection between the sets, the union, the difference between them. Sets are used when you don't want any duplicate values in your collection. And then lastly, we looked at dictionaries. Dictionaries are like dictionaries that we know. You have a key and a value. So you assign for each key, you assign a value or values. And then you can access those values. You can update them, change them, and the rest. And if you have any questions, please put them in the comments and I will try and answer as much as I can. Thank you very much.